Physics is the branch of science which we deal with like fundamental laws of the universe. We are studying about the universe, right? Now, for example, if we take something like mass, okay? So in this Zoom class, in today's class, I think there is one so I say this thing. So when I done with my OLS, so I also passed to age. So when I done with my OLS, so I had to choose comments for maths. But in my school, in the school I studied, we didn't have maths stream. So if I want to study maths, I have to go to a school. But in the same time, I don't want to leave the school because I studied from grade 1 to 9, so I attached to the school and I don't want to miss my students. So it was a big battle for me to choose commerce or maths. But commerce, I didn't want that because it's like what say, for example, I can say it's like from inside a bed. It sees only business and accounts, Java, but maths and science on the other hand. Here we study about, for example, I'll discuss in the physics point of view. Like here we study about how particles move, how planets move, how everything works out, right? Yeah. So in physics, and what can I say is those who are going to physics, you guys are really fortunate, right? Because physics is really an interesting subject. It's very interesting. Uh, Now, when you choose either biology or next subject, like, people may come and tell you you're going to do science is very hard. But trust me, in this world, we cannot define any subject as hard or easy. We cannot define any subject. Subject is hard, subject is easy. We cannot define. It's all depend on whether you are interested or not. If you are interested in a particular subject, let's say even like a rocket science, also rocket science, I can say yes, it's easy. Rocket science is easier than maybe easier than English literature, right? For me, I feel like that because I have interest in rocket science than the English literature, right? So it's all depends on whether the person is interested or not. And trust me, physics is really, really interesting. And what we are going to learn is 2 years on this year and so on. They are only a basic components of physics. There is no hard. Uh, Physics is really easy if you study it properly, and it's not like biology. I hope that these biology students don't take me wrong. In biology, you have to memorize a lot, but in physics, it's not like that. It's all based on logic. Now, for example, if I write a number, okay, this is a huge number, a big number. Have you ever seen this number before? I guess nobody have ever seen this number, even I haven't seen this. But still, I know how to add 1 to this number. So here we will get the same number and this number will be 8, right? So likewise, here there is a logic. Like that, physics also mainly based on logics. Okay. Now, for example, let's say biology. Biology. If you take biology, what is the fundamental unit? If I take biology, what is the fundamental unit that you learn in biology? Most probably like a cell, no? Cell or DNA. So these are the fundamental units of biology, biological units, right? And ecosystem and all. The fundamental one you take, you consider as a the tissue, sorry, cells and DNA structure. Those are the fundamental units of these biological systems, right? But if I ask you what is the foundation of biology? For example, if there's a building, it has a foundation. Likewise, if you take biology, what is the foundation of biology? Anyone tell me? You can unmute and talk, or you can drop a message in the chat box. I can view the chat box from here. Okay, tell me what is the foundation of biology? Biology, the foundation is the chemistry. Because if you take cell or the structures in cell, like carbohydrates, protein, these all are made up of molecules, no? Molecules and right? Now, for example, DNA also has some molecular structure, right? So the foundation of biology is chemistry, right? So what do you study in chemistry? What do you study in chemistry? Okay, in chemistry, what we learn, for example, let's say there is an atom. The atom has some electronic structure. Now, all of us, you have studied atoms, like electronic structure of sodium, chlorine, right? Those things we have learned in our science. Okay. So in chemistry, what we learn is now different atoms have different electronic structure. We can call that electronic different configurations are there. For a given atom, the configuration is unique. Now, for example, if I take sodium has only 11 electrons, right? And then magnesium has 12 electrons. Likewise, every atom has unique electronic structure. Due to this electronic structure, the atoms will make bonds, or they will react to another atom, right? So these reactions, bondings, and all responsible for the electronic structure, right? Now, for example, if I take sodium has how many electrons? 11. Sodium. So in the innermost shell, we have 2 electrons, and then we have 8. 1, 2, 3, 4, 5, 6, 7, 8. And in the outermost shell, we have 1 electron. Okay. So this electron is loosely bound and usually has requires some energy to hold this electron because it's far. Rather, it leaving it is easy. So what will happen is this electron will be ionized. So this sodium atom becomes a positive ion because it will now usually if you take an atom, it is electrically neutral. That means same number of protons and equal number of protons and electrons. Now here in sodium we have 11 protons and here 11 electrons. If we remove one electron, it has one electron efficiency, so that becomes positive one, right? And then if you take chlorine has 70 electrons. So in the outermost shell, it has 7 electrons. So it needs one more electron. So this electron will be occupied by the outermost shell of chlorine. So the chlorine gets one extra electron, negative charge. So chlorine becomes negative charge. So positive charge sodium, negative charge electron, chlorine. So we know you may have studied electrostatic that opposite charges are attracted. So these now sodium is positive, chlorine is negative. They will attract and they will make a bond which we call ionic bonds. In your chemistry class, in the first unit or second unit, you will learn about these bondings and electron structure. Okay, so that is the chemistry. That is what you will learn in chemistry. Now, if I ask you what is the foundation of chemistry? What is the foundation of chemistry? Now, for example, if you take your chemistry syllabus, you will learn quantum numbers, main quantum number, these quantum numbers has is unique for each atoms. So you will learn in your chemistry class. So where these quantum numbers are came from? And these now, for example, if I take now how many elements are there? It's more than 100 elements are there, right? But the chemistry, the birth of chemistry is something of 1900 to 1920. During this period only, the proton is discovered, right? Electron discovered, neutron discovered, right? At that time, they were only few atoms, right? Like copper, silver. They know only few materials, but like after say in 1920, with end of 1920, they almost know more than 50 atoms. But how they know? But in those time, in 1920s, those time they didn't have electron microscope. They had only optical microscope. Optical microscope has a limitation, no? It can see things to a certain level, where the length is something around 10 to the power minus 7 meter, like in the range of nanometer. It's zero point 0.1 nanometer. Beyond that, smaller than that, we cannot see. You may have learned in our class that optical microscope has a limitation, so that in order to get rid of that, we use electron microscope. But electron microscope is developed in 1960s. So before that, how these scientists got to know like more than 40, 50 atoms in the period? It is using the physics. So actually the foundation of chemistry will be physics. So in physics, in this era, it has developed quantum physics. So in quantum physics, they have like Schrodinger equation. Solving that Schrodinger equation gives some solution for these atoms, and using that, they have discovered um, many number of elements in that time. Okay, so not only biology or chemistry, if you take any science and technology field, the underlying principles are physics. Now, for example, I can say take computer science. So, in computer science, you do coding, programming, and networking, lot of things, web designing, everything. So, these everything works with the principle of what? Binary numbers, right? So, you may have studied in IT class or in else like logic gates, right? Logic gates and binary numbers. So these are the ones we are operating inside a computer. Now binary, so computer runs with bits, binary bits. So these binary, how we construct? We construct use potential difference. If a certain area has large potential, it is 1. And if the potential is 0, we call it 0. So those 1 and 0 circuits are synthesized. Circuits are made within the material, like we can use diodes, transistors, IC circuits to construct these logic gates and all inside a very small chips, right? So if you take any field, any scientific or technological field, the underlying principle is physics. So physics is actually the study of the universe, right? So everything, like if you take a biology, the speed of the red blood cell and all, we can explain using the theorems that we learn in the physics. Okay, so physics is really interesting subject. So I will then move on to the content of this syllabus. So we have 11 units for physics, 11 chapters. So first unit is units and measurements. Units and measurements. So in this unit, we will be discussing about the units of physical quantities like volume has units, and then force. So the energy, what is the unit of momentum? So these things we will study, and also like base units like fundamental units, supplementary units. So these in the units. And also dimensions. We will discuss about what is dimension. It's a new thing for A levels and A levels dimension. Then after that measurements. So measurements we will learn about. We will discuss on some measuring instruments like vernier caliper, traveling microscope, vernier spirometer, and also like some measurement techniques, and also the errors that will be can cause during the measurements. So these things we will learn in the measurements. So this is unit 1. And also in unit 1 we will be discussing about vectors also. And the second unit is uh, mechanics. So we have 11 units. Among these 11 units, the biggest unit is the mechanics. In fact, I can call this mechanics is the heart of the syllabus, or in fact, I can call mechanics as the heart of physics. Why I'm saying like that? Mechanics is the heart of physics. Because now, for example, if I take a heart, what it does, it supply blood to every part of our body, every cell, every nerve, every part of our body. It will supply the blood. Similarly, whatever theorems, the phenomena that we learn in mechanics will be applied to every part of physics. Like it can be particle physics, gravity, and electromagnetism, thermal physics, oscillation waves. So every part of physics, quantum physics, relativity, so thermodynamics, in every part of physics, we are using the theorems that we and the laws that we learn. So mechanics is the most important unit of physics. And the third unit is waves and oscillations. Waves and oscillations. So here we will be discussing about simple harmonic motion, and pendulum, periodic motions, and circular motion, and waves. Waves we will study what are the types of waves, EM waves, electromagnetic waves, transverse waves, progressive waves. So different types of waves and their properties, reflection, refraction, interference, and diffraction. So those properties also. And also we will discuss about the effect and sounds optics. Optics means light. We can remember that in you always will draw ray diagrams for lens and also those things also. And the fourth unit is heat or thermal physics. So heat, here we will be discussing about uh, heat transmission, like convention, heat energy, how we calculate those things we will learn in this. And the fifth unit is gravitation. Gravitational field. So by the way, this is the smallest unit in our set. Here, actually, I can finish this lesson in, like for example, if I have 4 hours, I can finish, or 3 hours, I can finish gravitation field. That's a small unit, so it's easy actually. 6, electrostatic field. Okay, so here this electrostatic. Static means not move. So here what we will be discussing about charges and their effects. Now, for example, like for example, plus and plus charge and minus charge, right? Those things, the effect of not moving charges, the charges with not moving. The static means it's not moving, it's stationary, right? So here we are discussing about the effects of charges which are not moving. The moving charge we will learn, that is dynamic electric field. So there, what is that? That is actually the electricity. In electricity, what we have moving electrons, right? So electrons are moving this direction means current is moving in the opposite direction. So there we have dynamic charges. The effects of dynamic charges is the electric current. So those things we will learn in our 8th unit. So 6 electrostatic field, 7 is magnetic field, and 8 electricity. So this is due to dynamic charges. And 9 we have electrons. So electronics is also a branch of science. For example, now you guys are able to be peacefully able to sit and listen to this lecture because we have electronic devices, which is our mobile phone or laptop, those things. Those are electronic equipments because they are made up of electronic, like for example, diode, transistor, IC circuit. These are electronic chips, electronic circuits, right? So that is we will learn in electronics. Now, by the way, for example, these electronics are made of most of the components, diode, transistor. These are made of uh, semiconductors, right? What is the semiconductor that we use to make these chips? Mostly silicon or germanium. Now, thankfully, the silicon is very abundant in our earth, right? Which means we can easily access it because the silicon is extracted from silica, sand. Sand is everywhere we can found. Now, suppose if silicon is rare like diamond, then you have to pay millions, like uh, like lakhs, like 30 lakhs, 40 lakhs to buy a phone. I'm saying silicon is rare like diamond, then you have to pay a lot of money to buy a phone. But thank God, silicon is found everywhere in earth because that silicon can be extracted from the sun, right? Okay. And the 10th unit, mechanical properties of mechanical properties of. So, in this lesson, we will be discussing about three mechanical properties, namely elasticity, viscosity, and surface tension. So, those three mechanical properties will be discussed in this lesson. By the way, yesterday I started this chapter for 2025 batch students, both 2025 batch students and also 2024 students. For them, for 2024 students, it will be like a revision. And then for 2025 express, they are theory class. For yesterday only I started this. Okay, and then we have the last lesson, matter and radiation. Matter and radiation. Okay, so these are the 11 chapters that we have in our syllabus. Okay, quickly note down. Here we can write. In matter and radiation, we will be discussing about subatomic particles, electron and proton, what is inside within a proton. Now, in your levels, you may have learned like the fundamental unit of matter will be like proton, electron. But here you will learn proton. Within a proton also we can find particles called quark. So proton is made up of two up quark and one down quark, and neutron is made up of two down quark and one quark. So these things you will learn in actually the particles introduction for a particle, and also the radiation, alpha radiation, beta radiation, gamma radiation, and those things, and decay process, those things. Okay. So here we have 11 units, 11 chapters. The biggest, only the first three chapters. Maybe these, if I take these two chapters, this is alone can be like more than 30% of the syllabus. The mechanics and waves and oscillation, these two are more than 30% of the syllabus, so that in your first term you will have only these two lessons, chapters. Okay. Mechanics is very big lesson. Now, for example, I can show you reader. Okay, I hope you are finished writing this. If you haven't finished yet, you can take a screenshot. Okay, now I told you, like, for example, you got a tree. So it has branches. So in this tree, we have electromagnets. Or thermal physics. The electromagnetism means the study of electricity and magnetic fields both together. You combine, that's electromagnetism. It's called electromagnetism. Thermal physics, gravity, and else particle physics, astronomy, where you study about planets, galaxies, astronomy, what are the other waves, and we have relativity, quantum physics, nuclear physics. Okay, there are more branches of physics. Now, if you want to understand, like, Now I can draw this is the stem. I can mark the stem as mechanics. So mechanics is very important mechanics. If you want to understand everything like very well, then you have to have knowledge in mechanics. If you want to understand the mechanics very well, you have to understand its rules. So what are the rules of this mechanics? The basic components of mechanics that we will learn is physical quantities. So you have to understand these physical quantities very well in order to understand mechanics. If you can understand mechanics well, then you can anything, any field in physics very well. Okay, this is not necessary to write just giving some illustration of the importance of mechanics and understanding its rules, which is physical quantities, because that is the first topic we are going to physical quantities, right? So we will first write the this chapter, first unit number 1. You can write the unit number 1, unit measurements. Okay, write down the topic. Units and measurements. By the way, this should be units, dimensions, and dimension units, dimensions. Menu maker मान units, dimensions, and measurements. Okay. So then we can write this as physical quantities. So we are going to learn the rules of physical quantities. So write down the physical quantities. Write down, put a subtopic physical quantities, and you can write down a property that can be measured, directly or indirectly. Indirectly in a physical system. In a physical system. A property that can be measured directly or indirectly in a physical system. The property that can be measured directly or indirectly in a system. Now, for example, if I take volume, right? Volume, if I put into a container which has calibrator, we can directly measure. Right? So, volume is a physical quantity that we can measure directly, right? But density, on the other hand, can we measure directly? No. First, we want to measure the volume, right? First, we want to measure the volume. Let's say, for example, we have a liquid, so we can measure the volume using into a calibrated container, right? For example, like this gas container. So here we can find like 1 liter, 500 ml. They are calibrated, right? So if the water level is up to 500 ml, then we know the volume is 500 ml. Right? So volume we can measure directly. Right? Now let's say we want to measure the density. Density we cannot measure directly. Right? So how can we measure the density? Because we want to measure the volume, which can be measured directly. And second, I can measure the weight or the mass of this liquid, right? How can we measure? Now, for example, if you have a balance, let's say electronic balance, so I can keep first I can keep this container with liquid. Let's say this is showing the value something like uh, say 520 gram. Okay, and then next what I have to do is I have to take this liquid into another container and then want to measure the empty container. Right? And then next thing I want to measure the empty container. So empty container, let's say it has a weight of 20 grams. Therefore the mass of the liquid will be 520 minus 20, 2500 gram, which is like equals to 0.5 sorry 0.5 kilo. Okay. Now we know that mass, if volume let's say is 500 milliliter, then the density we can measure. Density equals mass over volume. So here the mass is 0.5 and volume is 500 milliliter. So 500 milliliter I can write as 0.5 liter, half a liter. So the density will be 1 kilogram per liter. Okay. So likewise, we see we can measure direct. Right? We are measuring indirectly by measuring the minutes in the volume and then we are obtaining the density. Okay. So here a physical quantity is a property that can be measured directly. Okay, I hope we have finished this part. A property measured directly or indirectly. The next thing that we are going to see is the physical quantities. All physical quantities we can divide into two categories. One are called scalars. Scalars. The other group of physical quantities are called vectors. Right? So all the physical quantities we can divide into two groups. One is called scalar and the other is called vector. Right? So now, what are these scalars and vectors? Can anyone tell me what is a scalar quantity? What is a scalar quantity? You can unmute and talk, or else you can drop a message, drop a text through the chat box. Okay, thank good. Yeah, I got 3 correct answers. Good. One person saying scalar has only magnitude. Another person said scalars have only magnitude but no dimension. Scalars have only a magnitude. Scalars have only a magnitude but no direction. Vectors, on the other hand, it will have vectors have both magnitude and direction. They have both magnitude and direction. Scalars have only a magnitude. They have only magnitude but no direction. Vectors have both magnitude and direction. Right? Now, for example, we can say volume. Volume has only a magnitude, but it doesn't have any direction. It has no meaning, any meaning with direction, right? So volume is a scalar or time. Time has only a magnitude but no direction. So first we will write down some examples for scalars. Okay, I want an example from each of you. Can you tell me an example for scalar? Okay, I got one example, time. Okay, what else? I need an example from each of you. Mass, very good. Temperature, good. Density, good. Okay, so we will write down some example for scalar quantities. Mass, time, temperature, density, volume, speed, distance, energy. Energy also has only a magnitude but no direction. Refractive index, and electric current, etc. So these are examples for scalars. And tell me some examples for vectors. I will check the checkbox. Give some examples for vectors. Velocity, displacement, very good. What else? I got a pressure is not a vector quantity. Pressure is a scalar quantity. Pressure which should come here. Pressure, okay. Pressure has no direction. So what else? I got force. Yeah, force, momentum, displacement, acceleration. Very good, very good. Okay, so we will write down the examples of this. Displacement, velocity, acceleration, force, momentum. The momentum, there are two types of them. Linear momentum, angular momentum, both are vectors. And force, momentum, what else? Electric field intensity. Okay, you can write this down. So, put physical quantities, we can divide into scalars and vectors. Scalars have only a magnitude, but vectors have both magnitude and direction. So here, electric field, then we have angular momentum and torque. Torque is also a vector. Torque means the moment of force. Right? The moment of force is torque. Yes. Okay. Now, when it comes to the A levels, you should not study in this manner. Like in your orders, you may have done note earlier, you write notes, leaving that to study later. Like you just write down and you will think that I will learn this, study this later. In that way, you should not study A level. You have to study at that time instance. Like when you are writing this note means from this moment you have to start. You have to put it to your head. Don't leave it that I will just write the note and I will refer this later. Don't do that. You have to follow, like you want to study now. Now you should know. Hereafter you should know what is scalar means, what is vector means, and what are the examples for vectors and what are the examples for scalars. Okay. Okay, so now we know what are scalars and what are vectors, and then now we'll move on to units. So why do we need units? Question. Why do we need units? Appear units can go on. Why do we need these units? Now uh, imagine that I want to, let's say, I can't show you. Okay, let's say I want to make a table. Okay, I'll create this first. I need to make some tables for my class. Right? So, for example, now I am calling a carpenter. Mr. Pereira, I need to make some tables for my institution. So I need in this dimension. So I'm giving the dimension. I'm measuring the dimension using my palm. So I say 1, 2, 3, 4, 5 palms are there. So for example, it is not exact. Maybe like 5 palms. Let's say I take a big table and using my hand, then I get something like the length is 5 palms, okay? And the width, let's say I got 3. By measuring this way, I got 3 palms. Okay, so I'm calling and saying to this Mr. Pereira, I want a table with dimension should be the length 5 palms and the length is 3 palms. Okay, so or yeah, then he will get the the information from me and then he puts the table, and when he puts the table here, and when I measured it actually, it will be like the length will be 6 palms, and this will be let's say 3.8 palms. Because why? Because my hand has a small palm. Okay, actually my hand is basically small compared to this. So then the carpenter is using this palm. Then it won't give the same value, right? We are not communicating the same value, right? So that is a big problem. In order to avoid these things, we all can come to a convention where we have a standard system. So for example, if I take this length and let's say this length is I call something like 1 feet, 1 foot, then everyone will agree that if everyone know that this is the 1 foot, then it's same. Like likewise, we all have to come universally. We have to come to an agreement, a convention that this is this unit, this is the exact value of this. Right? Otherwise, we cannot precisely communicate the exact value. Okay. Okay. So here is start, or maybe like for example, I give you an example. Let's say I want to make a window, like so there is a house, there is a space like this. Okay. So if I want to make a windows, if I use my palms, it won't give the exact measurement to the carpenter. So to get rid of those things, we need to have a units. We need to have a unit system. Okay, so you can write a small question like why do we need units? Okay, so the answer we can write to communicate the exact value of the physical quantity, communicate the exact value of physical quantity precisely and accurately. By the way, you won't get a question in your exam paper. Why do we need units? This is just to get make our notes clean, and like as a science student, we should know these things, right? For that purpose only, we are. If you check like last 20 years of paper, you can't see any question in the exam paper. That's why. So units are necessary. Units are necessary to communicate the exact value of the quantity precisely and accurately. Okay, write down. Okay, and then we all have to come to some one agreement. For that, there is something called SI unit system. SI unit system. So SI unit system is introduced to have uh, like we all can come to agreement. Like now, for example, if we can't communicate these values accurately and precisely, then we can't do any scientific research. We cannot improve in technology wise, because we all have to mention the same value. Now, for example, let's say we have to do some research in nanotechnology. So we have to investigate in like size of very nanometers range. So there we have to use exact precise uh, measurement. Or maybe let's say we want to see, going to make a mobile phone. I'm going to make a mobile phone. So what happens now? I'll ask my semiconductor engineers to make a logic circuits in chips, right? And then I'll ask the manufacturing engineers to build it in the real uh, material. So if those people and these people doesn't have the exact measuring these things, they cannot communicate the exact value, right? So therefore, the unit system is very important. For that, the most accepted unit system is SI unit system, where SI stands for SI. The abbreviation of SI is System International. So System International is Latin word which has the meaning of international system. Right? So okay, so now the next thing what we are going to study is unit system. We have introduced 7 base units for 7 basic uh, physical quantities. We have 7 base units for 7 physical quantities introduced by SI unit system. Okay, so we will write the topic base units. Write down the topic base units. Okay, you can write there are 7 base units introduced by SI unit system. There are 7 base units introduced by SI unit system corresponding to 7 base physical quantities. Corresponding to 7 base physical quantities. Okay, so now what we are going to learn is 7 physical quantities and their base units, or we can call basic units or fundamental units. So base units also known as fundamental units, right? Fundamental units. Base units are also known as fundamental units. Okay, so we are going to see what are those 7 fundamental units and their physical quantities. So first, then symbol. Okay, the first physical quantity we can take time. Time is measured using the unit called seconds. Seconds, and the symbol is S. And the next one we have length. Length is measured by meter. The side of length is meter, and symbol is symbol. And then mass. Then SI unit name, kilogram. So symbol is simple K, simple G. Time, length, mass, temperature. Temperature measured in Kelvin, capital K. 1, 2, 3, 4. There are 3. Electric current. Ampere. Letter simple is capital A. Ampere. Electric current. Then we have luminous intensity. Luminous intensity. Luminous intensity is measured unit called candela. C-A-N-D-E-L. Candela. And the symbol, by the way, I tell you one more thing. When a unit represented by a special name, when a unit is represented by a special, the letter should be capital. The symbol will be capital. Now, special name is Kelvin. Kelvin represents a person. In order to honor Mr. Kelvin, the person who investigated the temperature and everything. So, in order to give honor, we have used symbol and the name Kelvin. So, it represents a person name, so it has to be Kelvin. Ampere, capital. For example, if I take Newton, Newton is not, it is not a base unit. I'm saying the unit is capital N. Whenever we have a unit with a special name, scientist name, the letter should be capital. Okay, that is very important thing that you should know when writing units. Okay, here luminous intensity is measured by candela. Candela is also a person who is investigated the intensity of light, the brightness of light, those things. So luminous intensity, that means the brightness. Luminous means the illumination, how much bright. Okay. So here candela is also a person name. So here we write capital C, simple D. But when I write like that, capital C, simple D, this is the element in the periodic table where cadmium. Because cadmium also we write like this. So in order to avoid that confusion, only for this scenario, the letter is written as simple C, simple D. So the symbol for candela will be simple C, simple D. Okay. So this is the unit of luminous intensity candela. So everywhere when the unit comes with a special name, it is capital. Only in this case, here we have candela C, but capital C will confuse with cadmium. So in order to avoid that, we use simple C as. And then we have luminous intensity, amount of substance. Amount of substance. amount of substance measured using the unit called mole, and the unit symbol is mole. Okay, so these are the 7 base units corresponding to 7 base physical quantities. Okay, you can write this down. Temperature is measured in Kelvin, capital K. And then electric current, ampere, capital A. Luminous intensity, candela, CD, simple C, simple D. Amount of substance, mole, simple M, simple O, simple L, mole. Okay, so here when we are choosing a unit, we have to uh, consider few things. The first thing is it should not be it should be invariable. That means it cannot vary. Now, for example, when I measure, if I use like for example, when I measure from Colombo, it shows one value. When I go to Candy, it shows another value. That means we cannot use that thing as a unit. The unit has to be have some properties, right? So this one also you won't be asked in any exam paper, but you should know about these things. There are a few properties that should be satisfied. One is accessibility. That means you should be able to easily access. Now, for example, if I say, uh, like if you want to measure the 1 kilogram, you always want to travel to Paris because the 1 kilogram that this thing is kept in Paris, right? So if you always want to go to Paris to measure the 1 kilogram, like one measure, then it cannot be a good measuring unit. It should be easily accessible, or we cannot take the mass of the sun, something like that. Something. And give me a second. Okay, so the first point I told, which we can easily access. Now, for example, as I told you, if you want to measure weight, you always want to travel like 2 to 3 kilometers or like 10 kilometers. Then it is not a good measuring. Right? Now we know 1 kilogram. Like for example, the 1 kilogram is actually it's a now the definition for 1 kilogram has been changed from 2019. But before that, uh, I will send you this picture of 1 kilogram, which is it's alloy made of platinum and iridium. So it is like inside the glass. This is inside a glass, two glass protecting this 1 kilogram thing, right? Because we have two class members, the mass of 1 kilogram should not weigh. That is also another property of a unit. a unit should not vary. It has to be invariable. That means it should not change with time. Now let's say this is the definition for 1 kilogram. We say this is 1 kilogram, and respect to this, the 1 kilogram weight has been made. The copies 1 kilogram is made and sent to all other countries. So this thing is there, still there in Paris. But now, from 2019, the definition was changed. It was defined using the Planck constant. Anyway, so that is one point. The units should be easily accessible. Okay. And the next one, the next point is it has to be invariable, right? That means it should not vary with time. Now, for example, we take the definition for time in seconds, right? But why can't we take 1 year? Year also some time, right? We can't take year. Year cannot take as a measuring unit for a time. What is the reason? The reason is because it is varies. Now, for example, 2023 may have 365 days and 365 days and 2 minutes maybe. Or in 2004, it will have 365 days and another 2 minutes and 5 few seconds. There are slight change in the seconds, right? Not every year have the same time span. So therefore, a year cannot consider as a good measuring unit because it varies year to year. Now, for example, we have this extending, where February 29 we can find, right? By the way, why we take that February 29? Why there is a additional day in every after 4 years? That is because the year is exactly not 365 days. It is 365 days plus some 4 hours, right? Something 4 to 6 hours, right? So for this, every year is 4 hours, not 4 hours, something around close to 6 hours. So every year this 6 hour will be added. So 1 year 6 hours, another year 6 hours means 12 hours, and the 3 years 6 hours means 18 hours. The 4 years 24 hours will be added, so it will be as an extra day every 4 years. Okay. That is in range of hours, but still has a slight change in seconds, right? So every year is not in the same length. The time span for the year is not same. Therefore, we cannot take year as a measuring unit, right? So the time measuring unit is seconds. The second is defined as it is actually the transition frequency between two orbits in a krypton or cesium atom. Okay. By the way, the definition also not necessary for you because in exam they won't ask any definition. But as a science student, you should know at least definition of these three: the time, length, and mass. These three definition at least we should know. We can search what is the definition of uh, seconds. What is the definition of meter? How the meter is defined? How kilogram is defined? So you can search in Google or YouTube and get what is actually second is defined, how meter is defined, how kilogram is defined. So I will give you some quick briefing about how these are defined. Second is defined as considering the transition frequency of cesium or krypton atom. There are two energy levels between that transition frequency. So that frequency is actually it's a big number, huge number, like 9 billions. That means in 1 second the electron jumps up and down more than 9 billion times. So that within 1 second that number of times it is oscillating. So according to that frequency only it is defined. The meter is defined using the speed of light, because speed of light is not changing anywhere in the universe. And then the kilogram is now defined. Earlier it has some copy of mass. Then due to respect to some other measure, now no longer this is using. Now the kilogram is defined using the pounds. Okay. So those are the properties of units. The units should be easily accessible. You can access the unit easily. Like if I say meter, I can take a meter over it. So the second one is it should not vary as it is like for example, it has to be same every time or every place, right? So that is another thing. It should not vary. That means say that in vary should not vary. Okay. Okay. So okay, again I'll just go through this. There are 7 base units: time, length, mass, temperature, electric current, luminous intensity, amount of substance. This is very important because this is the base of the units. So other units are made up of using this. All derived from this. One of these units is very important for you to study. Okay? Time is measured using seconds. Length is measured in meter. Mass kilogram, simple kg. Temperature Kelvin, simple capital K. Electric current ampere, simple capital A. Luminous intensity candela, simple C. Amount of substance measured from using mole, and the symbol is mole. Okay. Since today is our first day, I'm not going much into the syllabus. So today so far we learned only few things, right? But even these few things you should know by now, right? Like physical quantities we can divide into scalars and vectors. Scalars, what are they? They have only a example: mass, time, distance, speed, uh, temperature, electric current, refractive index, friction coefficient, relative density. Okay, so these are scalar quantity. Pressure, stress, and Young's modulus. These are not uh, scalar quantity. And vector quantities, they have both magnitude and direction. They have both magnitude and direction. Example, velocity, displacement, acceleration, force, momentum, angular momentum, torque, electric field intensity, magnetic field intensity. Okay. So then we have second now. Okay. So by the way, please try to search and refer the definitions. You can note down the definitions of all of this. So you can leave one page. That is not important for your exam, but as science students, you should have some idea what is the definition of seconds, what is the definition of meter, what is the definition of kilogram, what is the definition of Kelvin. All these things as science students, we should. Okay. So for that, I will I can request the first homework for you guys to do. What you can do is, when you have some pleasure time, just search definition of second. So you'll get the definition and then try to write it down. But it's not important for our exam, final exam. And also I have to explain you regarding the exam paper. So we have two papers, paper 1 and paper 2. So paper 1 has 50 MCQs. Paper 1 has 50 MCQs. So from this 50 MCQ, you will get one question from units. One question from the section we are learning now. You will get one or two questions. So if one question means either units or dimension, two questions means again units or unit and dimension. Like that, you will get at least one or two questions from this chapter. So 50 MCQs will be there. Each question get 1 marks. So if you get 50 correct, that means you will have 50 marks for your total paper. Because this 50 marks will be the 50 marks, 50% of the entire paper. So remaining 50% goes to this paper. Where in paper 2 you have two parts: structured essay, and we have essay. So structured essay, basically they are practical questions. Like you have to do some experiment, like practicals are there. There are 42 practicals in our syllabus. So from there, they give 4 practical questions are there. So you don't have to do practical like as practice. It's a written paper. It's only a written paper, but based on the practical knowledge. So in our physics paper, the easiest part where you can score marks is the structure, because that is exactly the theory. Now, for example, if you take last 10 years, you may notice two questions from same practical, right? Two questions from same practical. Check the questions, almost same question they will be repeated, but only one or two questions will be different, right? And those questions are from exactly from the theory, right? So the structured essay is the easiest place in physics paper where you can get good marks. But MCQ is bit challenging because you have to write answers 50 MCQs where you have within 2 hours. So each question you will get something around 2.2 minutes. Okay. And essay we have 2 parts, A, B. So in A part you will get mechanics question, waves and oscillation question. Like so here you have to do 4 questions. Here you get 4 questions. So until 8 questions. So this entire paper will be 50% of your exam. Okay. So here structured essay you get 20. Full paper you get 20 marks. This is 40, 40. So here you get 60. This is 40 and 60. And so 60 marks for this center, 40 marks for the surface. We add 100 and 100 will divide by 4 for paper. But here paper 1 MCQ you will get 50 MCQs, 50 marks. Okay, so that is the structure of the exam paper. Okay, so we studied 7 base units. Once again, one last time, 7 base units are there, corresponding to 7 physical quantities. What are those 7 physical quantities and their base units? First, time measured seconds. Time is measured from seconds, and then we have length, meter, mass, kilogram, temperature, Kelvin, and electric current, ampere, luminous intensity, candela, and amount of substance is measured from mole. And now next, this is base units, fundamental units. So these are the base units of fundamental units. Okay. And then we have supplementary units. Supplementary units. Write on subtopic supplementary units. At what time class finishes? We have scheduled the class 8:30 to 10:30. Do you guys want to have the today's session till 10:30 or 10? Can you drop a message? Since today is the first day, I don't want to 10:30. Okay. So we will have today's session till 10:30. So every Thursday we will have our 2026 physics online class from 8:30 to 10:30. But later I may extend the time. Like I will start from 8 and then it will go up to 10:30, or maybe in future 8 to 11 also can will happen. But for the moment, we'll just stick to 8:30 to 10:30. Okay, so supplementary units, you can write, there are two supplementary units. There are two supplementary units. There are two supplementary units. Okay, there are two supplementary units. So one is radian and then the other one is steradian. So the first one is radian. So here I write radian. So it is used to measure radian and radian is used to measure plane angle. Okay. So radian, I can by taking circle, here the center, and then this is radius, radius. The definition for radian is, I write down, the angle subtended by an arc, an arc of a circle that has the same length. The angle subtended by an arc of a circle which has the same length of the angle subtended by an arc of circle which has the same length as radius. Same length as the radius. The angle subtended by an arc of circle which has the same length as the radius. Okay, so here I have to take this the radius, same length. This has some the same length I have to draw this arc. So then the angle subtended here. The angle subtended will be 1 rad. It's defined as the radian. So radian, the unit is radian. The unit we write, for example, meter we write m. Simple is m. Simple is rad. So here is arc that is equal to arc that is equal to the radius. You can take any size of circle. If it's small circle, still the same. So here this will be the radius, then arc will be this. Then you will get the same angle, 1 rad. Okay, you can write this and draw this. So here this angle will be the 1 rad. Is the letters are clear or should I write in big letters? I think. Is it readable? Okay. So radian is a plane angle. Plane angle. The unit we use to measure plane angle is radian. So radian is defined as the angle subtended by the center of circle or arc which has the equal length of this radius. So the symbol is rectangle. Now we will see the relation between red and degrees. Okay. So here we know the entire complete circle has 360 degrees. 360 degrees. The full circle, the angle of the entire circle will be 360 degrees. So we know that 360 degrees corresponds to a length of 2 pi r. 2 pi r. Then side takes 2 pi side. 360 divided by 2 pi. Okay, so first here is 2 pi. I write this in radian. 360. Hold on, don't write. Yes. So we are going to obtain the relationship between radian and degrees, right? So here one rad is corresponds to one rad corresponds to arc length of r, right? Because this arc length is equal to the radius. And here the total internal angle is 360. 360 degrees is equals to in radians 25. 360 is equals to 360. One rad is equals to and again it's 360 is equals to 25. Okay, I will send you after the session. I will send you the relationship between 360 degree and radian. It's not a big thing, it's a small thing. I'm not getting it suddenly. So the next unit is stereo. The unit measure, the next one, we have two supplementary units. There are two supplementary units, radian and then steradian. Second one, steradian. Steradian. So this is used to measure solid diameter. Steradian is used to measure solid diameters. So solid diameter I can show you like this. We have the circle and then this is the center, and then we have one circle. So what we have is, as say we have a ball. In that ball, I am drawing circle. So we have a sphere. On that sphere, I am drawing circle. This area. Now, if this has a radius r, say radius r. If r is the radius, so this area we take as r square. Then the angle corresponding to that will be 1. Now here simple is equals to 1 SR, is the radian. Simple is SR. Simple is simple. Because radian, stereo, they are not any special names, so it has to be simple. Right? So SR, radian, so this is. So steradian is used to measure the solid angles. Okay, you can draw this down. So it is a sphere. In that sphere, its surface we have a circle, which is area is equal to r square. So the angle subtended by the center to this area will be the solid angle. So it is 1 is after this session, I will send you a small presentation, the WhatsApp group, where we have the definition of radian and the image. We can find this radian, their image. So you can, I will send you that after this class. Okay, so there are 2 supplementary units and then 7 base units. And 2 supplementary units, they are radian and steradian. Radian is used to measure the plane angle, steradian is used to measure the solid angle. Okay, so here we can write the radian and steradian. Or we will say plane angle and solid angle. Here we can write a point. Plane angle and solid angle are dimensions. That means no dimensions. Plane angle and solid angle are dimensionless quantities. Write down this point. Plane angle and solid angle are dimensionless quantities. That means they have no dimensions. Now, for example, length has a dimension, time has dimension, force has dimension. Like units have, physical quantities have dimensions, but this plane angle and solid angle have no dimensions. If you still don't know what is dimension, don't worry. Uh, in our next class, or maybe after the next, most probably in the next class, we will be studying what is dimension are. Right? So if you don't understand, it's totally fine. Okay. So plane angle and solid angle are dimensionless quantities. plane angle and solid angle are dimensions. By the way, this plane angle and solid angle, they are vector or scalars. Let me check box. This plane angle and solid angle, are they vectors or scalars? No idea. Scalars, yes. Okay. Because they have only 90 directions, so they are scalar quantities. So we studied base units and then supplementary units. There are two supplementary units: radian, which is used to measure plane angles; steradian, which is used to measure solid angles. And these two, plane angles and solid angle, have no dimensions. Okay. And then we have derived units. Okay, so derived units, for example, I'll give you a table. Physical quantity, and SI unit name, SI unit name, and we have simple. So, for example, area I can write as length into length. Or length into breadth. So, right? So length into breadth, that is meter into meter into meter. So simple will be meter square. So you can see this area has a unit called meter square, but it is derived using a base units. Okay. So first we can write the topic derived units. Okay. Write the topic derived units, and then write under that these units are derived. These units are derived. These units are derived. These units are derived using the base units. Derived units under that these units are derived using the base units. So, for example, area, if I take area, we have meter into meter. So, meter square, and volume. So, volume I will make meter cube. And then density we have kilogram divided by meter cube. of meter into meter into meter. So we get kg m minus 2. Okay, so here area meter into meter is equals to meter square. Volume meter into meter into meter meter cube. So volume is measured using the unit called meter cube. So it is a derived unit. It is derived using a base units. Now density is kg m minus 3. So it is derived using the base unit of mass and the base unit of length meter into meter into meter. Okay, so here you don't need to draw this. I'll give you, I will send you the full chart where you can have a lot of things that you can do as a homework. Okay, and the next thing is derived units with special names. So derived units with special names, for example, we have Newton, right? Newton, which is force. Force equals mass times acceleration. Therefore, we get kg ms minus 2. Force equals to ma mass times acceleration. So here kg m kg, sorry, kg ms minus 2, right? So this is actually Newton. So from base units, so this is Newton. Using the base units, we have kg ms minus 2, kg ms minus 2, and then like Pascal, capital P Pascal. So it is actually force over area, kg m minus 1 is minus 2. So pressure as unit Pascal. Pascal is a derived units with a special, right? And then we have done Farad, where we used to measure the capacitance. And then joules, we used to measure energy, joule, capital J for singular. So these are derived units with special units where we have capital. For example, start with scientific specific. Okay, so hertz frequency is measured from hertz, capital H, Z, and next we have frequency and voltage or potential difference. We used to measure voltage, so that is also uh, derived unit with special names. And charge, coulomb charge, Q equals IT. So Q measured charge is measured from coulombs, capital C, and I is ampere times second. So coulomb is equals to ampere second, right? So this is the derived with special name. Unit with the base units. Ampere is the base unit for measuring the current. Seconds is the base unit of measuring the time. Okay. So I will give you a small recap of what we learned. Today we studied physical quantities, right? So all the physical quantities can be divided into two categories. One are called scalars and another called vectors. Scalars have only a magnitude. Meanwhile, vectors have both magnitude and direction. The example for scalars are mass, because you can see we can mass have only a magnitude but not direction. Mass, time, temperature, electric current. Now, sometimes the students may confuse that electric current. It is flowing in one direction, so it has a direction. Some students confuse with that vector or scalar because current is flowing in one direction, so it is no. For example, if you take the wire and change the direction, nothing will change. Take a current electric wire, So here, if you take the wire, if you change, now let's say this to the computer, whatever things say, change the wire direction. Now current is flowing this direction. So even if I change the direction, nothing will happen. The mass, for example, this has mass. If I change the direction, nothing will happen. But force is a vector. If I apply the force from this direction, it will accelerate this direction. If I apply the force in this direction, it will accelerate this direction. If I apply the force downward direction, so you can see if the direct when the direction of the force is changing, the physical effect is changing. Therefore, force has a magnitude as well as direction. But current is a scalar quantity. Even though the current flow is in one direction, it is not that direction we are. Okay, so current is a scalar quantity. Okay, and the vectors, on the other hand, we can have examples as displacement, acceleration, velocity, force, momentum, torque, electric field intensity, gravitational field intensity, weight. Weight is actually the gravitational attraction force acting on myself. So it's my weight. So these are vector quantities. And then we discuss what is the need of a unit system, because unit is necessary to communicate the value of a physical quantity exactly and accurately. And then we studied 7 base units corresponding to 7 base physical quantities. The physical quantities are time, length, mass, electric current, uh, temperature, luminous intensity, and amount of substance. So we'll see the corresponding base units. Time is measured from seconds, length is meter, mass kilogram, temperature Kelvin, and electric current ampere, luminous intensity candela, amount of substance. Okay, so those are 7 base units, and then 2 supplementary units we studied. One is radian, which is used to measure the plane angles, and then steradian, which is used to measure the solid angles. The plane angle and solid angle have no dimension, because I'm repeatedly saying because they have been asked in MCQ questions. Which of these have no dimensions? From this given set of physical quantities, which set doesn't have dimensions, right? So plane angle and solid angle have no dimensions, but they have units where rad for the plane angles, per radian for solid angle. And then we have derived units. So derived units like volume, area, density, velocity, acceleration, force, momentum. So all these are derived using base units. These units are derived using the base units. That's why we call them derived units. Now, for example, if I take velocity, ms minus 1 meter divided by second. So base unit meter divided by base unit second. And if I take momentum, which is mass times velocity, right? So mass kilogram base unit. Velocity is also made of, it's a derived unit made of base units, meter divided by second. So it is also, so therefore momentum is altogether kg ms minus 1. Base unit. Okay, that is the momentum, unit of momentum. Okay, and then we have also have derived units with special names where Newton. So capital N, Joule, capital J, Hertz, HZ, Volt, capital B. So those are derived units with special names. Okay, so those are the things that we have discussed today, and we have to discuss this prefixes. Okay, so which means like milli, centi, deci. So we will see those things in our next week class. Okay, so that's all for today. Today, since our first day, I didn't do faster. We did only reaching, right? Because little by little we will increase. But when it comes to A level, you should not tell to yourself that you will study from this month, after 4 months, after 3 months. No, you have to start studying from now, right? Now you guys are very fortunate. You will have resource book for every subject. During when we are doing this exam, that time we didn't have those facilities. We didn't have resource books. If we had that, we would have already downloaded. Because when it comes to physics, when I learn something today, it gives the curiosity. What would be I learning next tomorrow? Like if we solve an equation like kinematics for that motion. If I learn something today, you should get that curiosity as a science student. You should not learn just on focusing the exam. You have to learn for your knowledge. You have to be curious. As science students, it's very important for you to be curious what would happen if this happens, what would happen. You have to think out of the box. Okay. So these things are very important. You have to think out of the box. You have to start working from today. Now, as I told you, you will have this resource book, so you can download it. If you don't know, you can go to NIE.research resource book. You can download for each subject, so you can as well. And you refer it. Refer. Don't wait until a teacher come and teach you. Until I come here and teach you. As science students, you have to seek the knowledge. You have to go. You have to, if you want to get good results. Now you may have like recently also got air results, right? So they might have island ranks, district ranks. To ask those students, they were saying like I was studying for 8 hours and I was studying 7 hours, right? Without just studying 2 3 hours, can't go up to that. You have to study from now, right? And I want each of you to get good marks. That is my objective. My target is whoever the student join here, I want to give my best that I can so that they can get marks. And also, now when it comes to O level, the teachers somewhat affects the students' performance. But when it comes to A level, it doesn't matter what I told you, how much I prepared, how well I teach. It is all up in the students. You have to do your homework. I mean, you have to practice more questions. Because in physics, take subject, for example, take equation of motion. There is no only one question. There can change the question like 1,000, 10,000 ways. So the question that can give is enormous. There's unlimited. So you have to be ready for all these things. So how we can get ready? How can we prepare for those things? You have to practice. And when you do practice questions, past paper questions, model questions, and these things again and again repeatedly, then you will see, okay, this way you learn. But if suddenly if a question comes to you, then if you don't know, it will be difficult, right? But if you already done this different method, like there can be like tons of method that we can give questions in physics, right? So you have to be prepared for everything. So you have to start studying from today. You have already started your process for getting 3 A's. I appreciate the applause, and you can start now. And please work well, study hard, study smart, and target for the best results. Okay. So from here, I'll finish the today's session. If you have any questions from what you have studied, okay, you may ask now. Okay, no, so everything is good because we didn't do anything like complex. So these things what we learned today, even older students can understand because our syllabus is prepared with something like that, with starting with something easy and then form to mechanics, etc. Okay, then so then I will wind up the session and we will have our next class on next Thursday, same time 8:30 to 10:30. So study well, take care, good night.